Now let us write a Python program to check whether a number p is a prime number or not. Okay, so you can start with a comment. Maybe a single line comment is enough to check. Not. Now you first p should be entered from the keyboard. So p is equal to int input. Now here you can write enter a number. Now I am going to check whether p is a prime number or not. P should be certainly greater than 1, because if p equal to 1, it is neither prime nor composite. If p is less than 1, certainly you don't need to check that, isn't it? So I am going to perform a condition check. If p greater than 1, you can check whether p is prime or not. Okay, so for the time being, what will I do? I will write an empty statement, pass. Later I will change this. Okay, now else if p equal to 1, what is the meaning? It is neither prime nor composite. So maybe you can write p is neither prime nor composite. Otherwise, what is the meaning of this else? P is not greater than 1, p is not equal to 1, so p is less than or equal to 0. Okay, so you can write prime numbers does not exist. So first you can write if like this. Now I am going to change this one. So I want to check whether p is a prime number or not. What is the method? When you divide p with any of the numbers from 2 to p minus 1, if p is exactly divisible by any of the numbers from 2 to p minus 1, it is a composite number. Otherwise p is a prime number, isn't it? So 2 to p minus 1, I want to get all the numbers from 2 to p minus 1. How will you get all the numbers from 2 to p minus 1? You can make use of a for loop for some variable name. Let me make use of I. Okay, so for I in range 2 comma p, and for loop should end with a colon. So what is the meaning of range 2 comma p? It returns all the integers from 2 to p minus 1. So here I gets all the numbers from 2 to p minus 1 one by one. What is the meaning of 1 by 1? Initially I gets 2. After that I gets 2 plus 1 3. After that I gets 3 plus 1 4, and so on. Okay, so anyway I contains all the integers from 2 to p minus 1. Now when you divide, if p is exactly divisible by any of the numbers from 2 to p minus 1, p is a composite number, isn't it? So I am going to check that. If p modulo I equal to 0. What is the meaning of this one? P is exactly divisible by I. P modulo I equal to 0 means p is exactly divisible by I. And what is I? Any of the numbers from 2 to p minus 1, isn't it? So p is exactly divisible by any of the numbers from 2 to p minus 1, meaning it is a composite number. So you can write print p is a composite number. Okay, and you don't need to check the remaining part, so you can break from the for loop. Okay, now when the for loop finishes execution, where will the control come? Just now I told you else. So for this, if you want, you can write one else. And in the else part, you don't have to do anything, just pass. Now when this for loop finishes execution, control will come to its else part, isn't it? So this else is actually for the for loop. So what is the meaning of for loop finishes execution? P was divided by all the numbers from 2 to p minus 1. It was not exactly divisible by any of the numbers from 2 to p minus 1. So for loop finished execution, control came to else part. Here you can write p is a prime number. So you can write print p is a prime number. Okay, so please understand the meaning of this else. This is actually for the for loop. Okay, so when for loop finishes execution, if premature termination of for loop does not take place, control comes to else part and you can conclude p is a prime number. Let me explain this code snippet. What is code snippet? Piece of code. Okay, so let me explain this piece of code with an example. Suppose p, the number entered from the keyboard is 4. P is equal to 4. We know that 4 is a composite number. Using this program, I am going to conclude that 4 is a composite number. Here, 4 greater than 1, condition true. So control comes inside. Now, for I in range 2, 4, what is the meaning of range 2, 4? 2 to 4 minus 1, 2 to 3. So here range function returns all the integers from 2 to 3. Okay, so I takes the first integer in the range, that is 2. What is p? 4. So 4 modulo 2, when you divide 4 with 2, the remainder is 0. So 0 equal to 0, condition true. So here you get the answer. 4 is a composite number and you break from the for loop. Break is made use of to exit from a loop. So you break from this for loop. Premature termination takes place. Okay, so you get the answer. 4 is a composite number. Okay, so actually I checked only one integer in the range 2. 3 is there to be checked. No need to check 3 because when you divide p with the first integer in the range, it is exactly divisible. So certainly this 4 is a composite number. Program concludes. Second time when I run the program, suppose p entered from the keyboard is 5. We know that 5 is a prime number. Using this program, I am going to check whether 5 is prime or composite. Okay, now 5 greater than 1, condition true. So control comes inside. Now range 2, 5 returns all the integers from 2 to 5 minus 1, 2 to 4. So here you get the integers 2, 3, 4. I takes the first integer in the range 2. 5 modulo 2, when you divide 5 with 2, the remainder is 1. 1 equal to 0, condition wrong. So control goes to the else part, nothing to be done. Okay, now I takes the next integer in the range 3. 5 modulo 3, when you divide 5 with 3, remainder is 2. 2 equal to 0, wrong. Control comes to else part, pass, nothing to be done. Again, I takes the last integer in the range, that is 4. So 5 modulo 4, when you divide 5 with 4, remainder is 1. 1 equal to 0, wrong. So control goes to the else part, pass, nothing to be done. So I took all the integers in the range. Okay, this for loop finishes execution. Here premature termination did not take place. So when for loop finishes execution, control will go to the else part of for loop. Okay, and here you get the answer. 5 is a prime number. So this is how you check whether a quantity is a prime number or composite.